So in math today we're going to start a new topic which is called trigonometry. So trigonometry is defined as the study of sides and angles in a triangle. It is defined as the study of sides and angles in a triangle. So let us look at the structure of the triangle. So a triangle is drawn in this way. And on this triangle, you're supposed to identify some parts. So this is a right angled triangle. So this is a right angled triangle. For example, this is A, B, C. And you have an angle here, which is angle theta. So this means the length that is opposite to the 90-degree angle, this is referred to as the hypotenuse. This is referred to as the hypotenuse. Then the side which is opposite to angle theta, this side is referred to as the opposite. And the side that remains here is the adjacent. Is the adjacent. So these are the parts that you're supposed to know on the right angled triangle. Let us look at an example. So if you have been given this triangle A, B, C, and you have been given these two parts, for example this is 6 centimeters and this is 2 centimeters, and you have been told to calculate length AC. So to calculate length AC, we are going to use Pythagoras theorem. So we are going to say AC squared is equal to, so if you are calculating the hypotenuse, you are going to add these two sides. You are going to add these two sides. So we are going to add AB squared plus BC squared. So AC squared is equals to AB, that's 6 squared plus 2 squared. So AC squared is equals to 6 squared, that's 36, plus 2 squared, that's 4. So AC squared, that's 40. So to find the value of AC here, we're going to say square here, square. AC is equal to, so 40, the square root of 40. That's 6.32 if I round off to 2 decimal places. So that's the length of AC.
So under trigonometry today we're going to be looking at SOHCAHTOA. So SOHCAHTOA is the formula that is used for right angled triangles. So it is the formula that is used for right angled triangles. Take note of that. So we are looking at SOHCAHTOA. And in this SOHCAHTOA we can draw up 3 equations. So the first one, we have sine theta is equal to opposite over adjacent. Then the second one, we have cos theta is equal to opposite over adjacent. In the third one, we have tan theta is equal to this one, cos theta is equals to adjacent over hypotenuse. Then this one we have tan theta is equal to opposite over adjacent. So these are the formulas that you use when calculating the angles or the sides of the right angled triangles. Let us now look at some calculations, and in these two calculations that I'm going to give you, we are going to calculate the angles. So we'll be calculating the angles. And the first example, if the triangle is in this form, and I have A, B, C, and I know that this is a right angled triangle, then I have angle theta here, then this side is 3 centimeters, and this side is 8 centimeters. And the question says I need to calculate angle theta, which is at A. So for me to find angle theta, I'm going to write my formula somewhere, which is SOHCAHTOA. And from this formula, I need to identify the sides. So I know that the angle that is the side that is opposite to the angle given inside, this is the opposite. Then the side that is opposite to the 90-degree angle, this is the hypotenuse, and the remaining side is the adjacent. And in this question have been given the opposite and the adjacent. So in this formula, which is SOHCAHTOA, I'm going to see which formula has the opposite and the adjacent. And from this formula is this one, which has sine theta. So I'll say sine theta is equal to opposite over adjacent, and I'll say sine theta is equal to, my opposite here is 3 centimeters, so I'm just going to write 3 divided by my hypotenuse here is 8, so I'm having 8. And for me to find theta here, I'll say theta is equal to sine inverse, so sine inverse of 3 over 8, and sine inverse of 3 over 8, I'm having 2.02 degrees if I round off to 2 decimal places. So that's how you can calculate the angle at theta. Let's take into another example. So another example, the triangle is in this form. And this triangle is a right angled triangle, and we have side A, side B, and side C. Side BC, I'm having 8.6, so this is 8.6 centimeters. Inside AB, that's 7.6 centimeters. And have been told to calculate the angle which is at point C. So angle theta, which is at point C. So the first thing that I'm going to do is to write my formula, which is SOHCAHTOA. And since I've written my formula, the next thing I need to identify the sides. So the side that is opposite to the angle that is given, this is the opposite. Then the side that is opposite to the 90-degree angle, this is the adjacent. Then the remaining side is the the hypotenuse. And the formula that I need to use must contain the opposite and the adjacent. And the formula that I can use, considering the sine one, it has the opposite and the adjacent, so this means this one cannot apply. What about this one, which has the adjacent and the hypotenuse? Even this one won't apply, but the one that has tan is going to apply, since I'm having the opposite and the adjacent. So I'll say tan theta is equal to opposite over adjacent. So tan theta is equal to opposite, that's 7.6, so 7.6 over adjacent, that's 8.6. And for me to calculate angle theta, I'm going to say the angle theta is equal to tan inverse, so tan inverse of 7.6 over 8.6, and punching this on the calculator, it's giving me 41.45 degrees if I round off to 2 decimal places. So this is how you calculate the angles in a right angle triangle using SOHCAHTOA. So we are going to proceed on SOHCAHTOA, and now we're going to be finding the side when given one side and an angle. So we'll be using SOHCAHTOA because the triangles that we're still using are right angled triangles. So let us look at this example. In this example, the first thing that we're supposed to do is to identify the sides. So the side AC, that's the hypotenuse, because it is opposite to the 90-degree angle, and side BC, that's the opposite, because it is opposite to the angle given, and the remaining side is the adjacent. So the next thing that you're supposed to do is to write the formula of SOHCAHTOA. So this is SOHCAHTOA, and from this formula we need to identify the formula that we can use to calculate angle AB. So we need to consider the adjacent and the hypotenuse, and from this formula we know that cos has both adjacent and the hypotenuse. So I'm going to say cos theta is equal to adjacent over hypotenuse. So cos theta here, the angle at theta is 32 degrees, so I'm going to write cos 32, I'm sorry about that. So cos 32 is equal to, the adjacent is the length that I'm trying to calculate, so adjacent over hypotenuse, that's 8 meters. So for me to find the adjacent, I'll say cos 32 multiplied by 8. So adjacent is equal to, if you punch that on the calculator, it's giving me 6.78 meters if I round off to 2 decimal places. So this means length AB is equal to 6.78 meters. That's length AB. So in trigonometry, In the first section, we looked at on how you can find the angle and the sides of a right angled triangle, and we looked at on how you can use SOHCAHTOA and how you can use Pythagoras theorem. So we're going to proceed, and today we'll be looking at non-right angled triangles. So a non-right angled triangles is in this form. So I have this triangle ABC, and I need to identify the sides. So the side that is opposite to A is written as a small letter A. Then the side that is opposite to B is written as small letter B, and the side that is opposite to C is written as small letter C. And the first thing that we're going to look at is the sine rule. So for the sine rule, we can say A over sine A is equal to B over sine B is equal to C over sine C. So this means that A, which is this part, is over sine A. The angle which is at A is equal to B, this part, the opposite, that is from the B side, over sine B, the angle which is at B. Then C means that the side which is this part, small letter C, over sine C, which is the angle which is at C. This formula can also be written in this form, where you have sine A over a small letter A is equal to sine B over a small letter B is equal to sine C over a small letter C. And the next thing that we're going to look at is an example. So for the first example, I have triangle ABC, and angle ABC is 60 degrees, angle ACB is 50 degrees, and side AC is 7 centimeters. The question reads, find AB. And for me to find AB, first of all, I need to identify the sides. So the side that is opposite to A, this is small letter A. Then the side that is opposite to B, this is small letter B, and the side that is opposite to C, this is small letter C. And have been given the angle which is at point B and the side which is from point A to C, and I'm told to calculate side AB. So I'm going to say, I'll say B over sine B is equal to a small letter C over sine C. Then B here is the length, which is 7 centimeters. So I'll say 7 divided by sine B. The angle which is at B is 60. So I'll say sine 60 degrees is equal to C is the length that I'm trying to calculate, which is length AB. So I'll say C over sine C. Sine C is the angle which is at point C. So this is sine 50 degrees. Then I'll say 7 over sine 60. If you punch on the calculator, that is going to give you 0.87. If you round off to 2 decimal places, C over sine 50 degrees, if you punch on your calculator, it's going to give you 0.77. if you round off to 2 decimal places. Then if you reach at this step, you can cross multiply. So this means 0.87 multiplied by C, I'm going to have 0.87c is equal to, then 7 multiplied by 0.77, I'm having 5.39. So to find the value of c, I would divide by 0.87 and this side 0.87. So the value of c is equal to, so 0.87 and 0.87 can cancel out, so I have 5.39 divided by 0.87, and my answer, I'm having 6.2 centimeters. So this is the value of AB. The value of AB is 6.2 centimeters. Let us look at another example. So for the other example, the triangle is given in this form. So for the second example, I have triangle ABC. So angle CAB is 120 degrees and side BC is 15 centimeters, side AC is 6 centimeters. Then I'm supposed to calculate, the angle which is at point B. So I'm supposed to calculate the angle which is at point B. So this angle here, which is at point B. So I'm going to write my formula. Before I write my formula, let us identify the sides. So the side that is opposite to A is a small letter A. The side that is opposite to B is small letter B. The side that is opposite to C is small letter C. And I'm going to say B over sine B is equal to A over sine A. B is the side which is opposite to the angle which is B, which is 6 centimeters. So I'm going to write my 6 over sine B is the angle that I'm trying to calculate, the angle which is at B. So this will be sine B is equal to A. What's my A? My A here is 15 centimeters. So I'll write 15 divided by sine A. Sine A, the angle which is at A, which is 120 degrees. So sine 120. And after that, we can say that we can cross multiply. So sine B multiplied by 15, I'm going to have 15 sine B is equal to 6 multiplied by sine 120. I'm having 5.196. So I'm having 5.196. And to find the value of B, I'll divide by 15 and this side by 15. 15 and 15 will go, so I have sine B is equal to 5.196 divided by 15. I'm having 0.3464. So this is 0.3464. And to find the angle which is at B, I'll say B is equal to sine inverse of 0.3464. So the angle which is at B is equal to sine inverse of 0.3464 is 20.27 degrees. So this is the angle which is at point B. The next thing that we're going to talk about is the cosine rule. So the next thing that we'll be looking at is the cosine rule. So the cosine rule is used when you have been given the three sides, or when you have been given two sides and an angle. So the cosine rule is used when you have been given the three sides of a non-right angle triangle, or when you have been given two sides and an angle. So those are the conditions. So let us look at the structure of a non-right angled triangle. So I have my A here, I have B, I have C. So the length that is opposite to A here is small letter A. The length that is opposite to B is small letter B. And the length that is opposite to C is small letter C. And the general formula that we use is A squared is equal to B squared plus C squared minus 2bc cos A. So this is the cosine rule formula. So you start by saying first A squared is equals to B squared plus C squared minus 2bc. So these two, the B and the C, then cos A. Then the other formula that we use, we say B squared is equal to A squared plus C squared minus, in this case to be 2ac cos B. Then the other formula that you can use is C squared is equal to A squared plus B squared minus 2ab cos C. So this is the other formula that we can use. So these are the formulas that you need to know. And the next thing that we're going to look at are some of the examples. So under the cosine rule, we are going to proceed and we're going to look at an example. And we said that you can use the cosine rule when you have been given two sides and an angle, or when you have been given three sides. And in this case, for this triangle ABC, we have been given two sides and an angle. So length AB is 5 centimeters, length BC is 8 centimeters, and angle ABC is 112 degrees. And the question reads, find AC. And before we find AC, let us identify the parts of this triangle. So the length that is opposite to A, this is small letter A. The length that is opposite to C, this is small letter C. And the length that is opposite to B, this is small letter B. So I'm trying to calculate length AC, which is small letter B. So my formula is going to have B squared is equal to A squared plus C squared minus 2. Then I'm going to get these two letters, so it will be 2AC cos cos here, the angle that I'm going to get is the angle that is at B. So the angle B. So I'll say B squared is equal to the length A, that's 8, so that's 8 squared, plus C here, the length C, that's 5, so that's going to be 5 squared minus 2 multiplied by 8 multiplied by 5 multiplied by cos B, the angle which is at B is 112 degrees, so that's 112. So B squared is equal to, so if you punch 8 squared plus 5 squared minus 2 multiplied by 8 multiplied by 5 multiplied by cos 112 on the calculator, you're going to have 118.969. so that's 118.969, and to find the value of B here, I'll say a square root here and a square root this side. So this and this will go, so my B is equal to the square root of 118.969. I'm having 0.907, so that's 10.907. So 10.907. So I can say here my length AC is equal to 10.907 centimeters. So this is the length of AC using the cosine rule, and remember that we had two sides and an angle, and we were supposed to calculate this length here. So in this video we're going to proceed, and we're going to proceed on the cosine rule, and we're going to look at on how you can find the angles when you have been given the three sides of a triangle. And I have triangle ABC, and from this triangle ABC I need to identify the part. So the part that is opposite to A, that's small letter A, the part that is opposite to B, that's small letter B, and the part that is opposite to C, that's small letter C. And as you can remember, we actually wrote our general formula that we use for the cosine rule when you have been given the two sides and an angle. So we said that that's A squared is equals to B squared plus C squared minus 2BC cos A. And if you have been told to calculate angle A, you need to make cos A the subject of the formula. So let's just put this on another page. So just writing it on another page, we are going to write the same formula. So we are going to say A squared is equals to B squared plus C squared minus 2BC cos cos A. And to make cos A the subject of the formula, the first thing that I'm going to do is to transpose negative 2bc cos A to the other side of the equation. So if it is transported to the other side of the equation, it will become positive. So that's going to be positive 2bc cos A. Then I already have a squared, so that's going to be plus a squared is equal to b squared plus c squared. And the next thing that I'm going to do is to transpose my a squared to the other side of the equation. So I'm going to write 2bc cos A is equal to b squared plus c squared, and when a squared is transported to the other side of the equation, it will be negative a squared. And to find the value of cos A, I'll divide both sides by 2bc and this side by 2bc. So 2bc and 2bc, they're going to cancel out. So I have cos A is equal to b squared plus c squared minus a squared over a b c. So this is the formula that you use when calculating the angle at A. What about if you are calculating the angle at B? So that's going to be cos B is equals to a squared plus c squared minus b squared over 2ac. What about if we are calculating the angle at point C? So that's going to be cos C is equal to a squared plus b squared minus c squared over 2ab. And the next thing that we're going to look at is an example that we can find using these formulas. And for this example, I have the triangle in this form, and this is triangle ABC. This triangle ABC, and the side AB, the side BC is 5 meters, the side AC is 6 meters, and the side AB is 7 meters. And for example, if the question says find angle C, so it means the angle that is at C, and before I find the angle at C, I need to identify the parts. So the length that is opposite to A, that's A, the length that is opposite to B, that's B, and the length that is opposite to C, that's C. So I'm trying to calculate the angle that is at point C. And the formula that I'm going to use, so I'm going to use that one which has cos C, since I'm trying to calculate the angle at point C. So I'll say cos C is equal to a squared plus b squared minus c squared over 2ab. So I'm going to say cos C is equal to A. I know that A, that's 5, so that's 5 squared. Sorry about that. So I know that A, that's 5 squared, then B, that's 6 squared, minus C, that's 7 squared, over 2 multiplied by A. I know that's 5, and B, that's 6, so multiplied by 2 multiplied by A, that's 5, multiplied by 5 multiplied by B, that's 6, So let me just write that properly. So that's cos C is equal to 5 squared plus 6 squared minus 7 squared over 2 multiplied by 5 multiplied by 6 . So I'm having cos C is equal to, so if you punch on the calculator 5 squared plus 6 squared minus 7 squared, that's going to give you 12 over, if you punch on the calculator 2 multiplied by 5 multiplied by 6, that's 60. So to find the value of C, I would say angle C is equals to cos inverse of 12 divided by 60. So if you punch on the calculator cos inverse of 12 divided by 60, that's going to give you 78.46 degrees. 78.46 degrees. That means that the angle that is at point C is 78.46 degrees. Trigonometry, we are going to proceed, and today we're going to look at the difference between the sine rule and the cosine rule. I saw that Maria was having some challenges on how to differentiate the sine rule and the cosine rule. I hope this video is going to be helpful to Maria and everyone who's not clear about the difference. So we're going to start with the sine rule. So the sine rule is the first thing that we're going to start with. So you use the sine rule when you have been given, so I was saying you use the sine rule when you have been given two sides and one angle. So when you have been given two sides and one angle, that's when you use the sine rule. Or you use the sine rule when you have been given two angles and one side. But it also depends on the side that you have been taught to calculate, or the angle that you have been to calculate. It depends with that question. That's when you're going to use the sine rule. So the triangle that you can use the sine rule can be given in this form. So for example, this is A, B, and C, and they have been given the angle here as 2 degrees, and another angle here as 4 degrees, and you have been given the length here as 4 centimeters. And for example, in the question, if you have been told to calculate the length of SC here, so for SC, you know that this B is opposite to B. So here there is a B, here there is a C, here there is a small letter A. So this means you can use the sine rule. And how you can use the sine rule, we know that this sine of the angle of B here, which will be sine 2 divided by B here, and we're going to say sine 40 divided by 4. And the reason why you're going to use the sine rule is because you have been told to calculate this length. So here you can say sine B over small letter b is equal to sine c over small letter c. So here you can say sine 2 divided by b is equal to sine c, that's 4 divided by c, that's 4 centimeters. And from here you can calculate the value of b. So this is how you can use the sine rule when you have been given two angles and one side. Let us look when you have been given two sides and one angle. So where you have been given two sides and one angle, so I'll give another example here. So it actually depends with the side or the angle that you have been given. It will depend whether you're going to use the sine rule or the cosine rule. So you need to make sure you know these questions. Where you have been given two sides, for example, this is 5 centimeters and this is 2 centimeters. And here you have been given the angle as 7 degrees. And if you have been told to calculate this angle here, the angle which I can say x, so before calculating x here, we know that here there's small letter b, small letter a, small letter c, and we can calculate the value of x here by using the sine rule, and we can say sine b here. So sine b over small letter b is equals to sine, we have been given we are being told to calculate the value of x here, so it will be sine c over a small letter c. So sine b, that's 7, so sine 7 divided by b here, that's 2, is equal to sine c here, that's x, we say sine c divided by c here, that's 5, and from here you can calculate the angle that is at c. So this is how you use the sine rule. So you use the sine rule when you have been given two sides and one angle, or when you have been given two angles and one side. It also actually depends with the angle or the side that you have been told. Let us look at the cosine rule. So we use the cosine rule when you have been given two sides and one angle. So two sides and one angle. So here you must pay attention. You see the side that I'll be calculating and the angles that I'll be given. They'll be given in a particular way. And you can also use the cosine rule when you have been given three sides. So if you have been given three sides, you're going to be asked to calculate one of the angles. Let us look at an example. So example here, so the triangle that you can use, the cosine rule can be given in this form. So here you have A, B, C, and if you have been told that AB here is 2 centimeters, AC is 3 centimeters, and you have been given the angle here as 5 degrees. So as you can see here, the angle will be given between the two lengths that you have been given, like for example AB and BC, and you have been told to calculate the length BC here. So the length that is on the bottom part of the both of the length that have been given, which is AB and AC. So this means you are going to use the cosine rule. Here you cannot use the sine rule. In the case you have been told to calculate BC. So if you are trying to calculate BC here, so we can only say that sine A divided by small letter a, and we don't have another angle here, so it means that cannot be possible. So I hope you get the point. So you use the cosine rule when you have been given two lengths here. Just a moment. Boy, listen. You need it, kaya
tutorial afana many awaiziwa. So wansokoneza hapa. Wansokoneza hapa. Ugola tembo. Ndishinza kuchita continue first nsirizo manyoma. Nza kutextinga pa WhatsApp. Alright, boy. Yeah, so here BC, we are going to use the formula of the cosine rule. So we are going to say, since we are trying to calculate, so here there is small letter a, small letter c, the small letter b. So we are going to say a squared is equals to b squared minus c squared, plus c squared minus 2bc cos a. So this is the formula that we are going to use. I hope you have known the difference, but where you still have challenges, you can ask your questions. Let us proceed. Then I'm going to solve the question that I had given Maria and Marjorie to solve. So the first question, I'm going to solve the one that I had given Maria. So check it out. It is there in the group, but I'm going to post it again. So this is K R here, N excuse. So this is the question, and the question was find KR. That's the question that I had given Maria to solve. Find KR. So to find KR, here let me identify first the things that have been given. I've been given the angle at R, I've been given the angle at N, I've been given the length KN. Then I also know that NB, that's 50 meters, and I'm told to calculate KR. So here I need to know that which formula am I going to use. Is it the cosine rule or is that of the sine rule? So here I've been given two angles, as you can see, this angle and this angle, and I'm trying to calculate the length KR here. So this means I'm going to use the sine rule. And the reason why I'm going to use the sine rule, this is because angle at R here, it has the opposite length here, which is this. Then the angle here, 60, it has the opposite here. So I'm going to calculate the angle here. If I try to use the cosine rule, that is not going to apply. I hope that's clear. So let me just write my opposite length. So here R, here is small letter R, then here we know that this is N, small letter N here, then here small letter K. So I'm going to say sine N over N is equal to sine R over R. Sine N here, I know that that's sine 60 divided by N is the length that I'm trying to calculate, which is KR, is equal to sine K. Sine K
the length which is at sine, not sine k, sorry, but sine r. So sine r, the length which is at r is 52. So sine 52 over r here it's 80. So here I know that n multiplied by sine 52, I'm going to have sine 52 n is equal to sine 60 multiplied by 80. I'm having 69.28203223. So to find the value of n, I'll say over sine 52 over sine 52. So here n is equal to, so if I divide 69.28203223 over sine 52, I'm having 87.92 meters if I round off to 2 decimal places. I hope this question now it's clear, but where you still have questions, ask. Let us go to the other question that I had given Marjorie to solve. So this was in this form. MKN, then MK was given as 8 kilometers, NM was given as 10 kilometers, then the angle at M was given as 92 degrees. So as you can see here, I have this length which is MK, which is 8 kilometers. I have the length NM, which is 10 kilometers. And considering from the two formulas, I'm going to use the cosine rule. And the reason why I'm going to use the cosine rule is because I'm trying to calculate this length, which is Kn. From the question, I'm told to calculate Kn. So Kn, as you can see, we have two sides here, and these sides, they are touching this angle. So this means I can say m squared is equal to, let me just put my small letters here. There's m, here there's small letter k, and here there's small letter n. So I'm going to say m squared is equals to k squared plus n squared minus 2k n cos m. And I know that this will be m squared is equals to k, here I've been given as 10, so this is 10 squared plus n, that's 8 squared minus 2 multiplied by k, that's 10 multiplied by n, that's 8 multiplied by cos the angle which is at m, that's 92. So here I'll say m squared is equals to, so if you punch out the calculator, 10 squared plus 8 squared minus 2 multiplied by 10 multiplied by 8 multiplied by cos 92, that is giving me 169.5839195. So that is giving me 169.5839195. 195. So I'm going to say square root here and square root here. So the square root and the square will cancel. So I'll say m is equal to, so the square root of 169.5839195, I'm having 13.02 kilometers. So I'm having 13.02 kilometers if I round off to 2 decimal places. So that means the length kn is equal to 13.02 kilometers. I hope you have now known how to differentiate the sine rule from the cosine rule, of the cosine rule from the sine rule. But where you still have questions, ask in the group. So on the cosine rule, we are going to proceed, and today we are going to be dealing with angles. So you can find the angle of a non-right angle triangle when you have been given 3 sides, and this is only taken into consideration when you are using the cosine rule. So if you are using the cosine rule to calculate the angle in a triangle, you are supposed to be given the 3 sides. So that's the requirement. So here the 3 sides are supposed to be given. So 3 sides supposed to be given in the equation. And if you remember very well, we said that the formula that we had written, we said if you remember very well, we said that our formula can be written in this way: a squared is equal to b squared plus c squared minus 2bc cos a is what we said. And we said that if we have been given a non-right angle triangle in this way, and if this is a, if this is b, and if this is c, this means that this is small letter a, this is small letter b, and this is small letter c. So when we are using the cosine rule, we use this formula. But imagine that all these 3 sides we have been given. We have been given a, small letter a, we have been given small letter c, and small letter b. And for example, if you have been told to calculate the angle at b, or at c, or at m, so this is what we are going to be doing in today's video. So for example, if you have been told to calculate the angle at a, the first thing that we're going to do is to transpose negative 2bc cos a to the other side of the equation. So when negative comes to the other side of the equation, it will be a positive, isn't it? So it will be 2bc cos a plus, here we already have a squared is equal to b squared plus c squared. And since here we need to get rid of a squared, this will go to the other side, and since this is positive, when it goes to the other side to become a negative, so this is going to be 2bc cos a is equal to b squared plus c squared minus a squared. Then the next thing that I'm going to do here is to divide both sides by 2bc and this side by 2bc. So this and this can cancel, So this means we're remaining with cos A is equal to B squared plus C squared minus A squared divided by 2BC. So this is the formula that we use when we are calculating the angle at A. What if we are calculating the angle at B? So if we are calculating the angle at B, we can say cos B is equal to, so in this case it will be A squared plus C squared minus B squared divided by 2AC. So you just get these first two letters that you have written on the bottom part. What if you are calculating the angle at point C? So this will be cos C is equal to A squared plus B squared minus C squared divided by 2. You get these two letters, so this will be 2AB. So these are the formulas that you need to know. And now we are going to look at an example. And for this example, we have triangle ABC. So let me just scroll this down. Okay, let me just put another page here. Okay, so I have this triangle as an example. This is too big. Okay. I have A here, then I have my B and my C here. Then length AB, I know that this is 7 centimeters, and length AC, that's 6 centimeters. So this is centimeters. And length BC, that's 5 centimeters. And if I'm told to calculate the angle at point C, so the angle here at point C here, so this means I need to use that formula that has cos C. So I'll say cos C is equal to A squared plus B squared minus C squared divided by 2AB. Then I'll say cos C is equal to, let me place my small letters. I know that this is A, this is B, this is C. So my A here, I know that's 5. So that is going to be 5 squared plus B here, that's 6 squared minus C. What's my C? My C is 7. So 7 squared divided by 2 multiplied by 5 multiplied by 6. So that is going to be cos C is equal to, so if you punch on the calculator, 5 squared plus 6 squared minus 7 squared, that is going to give you 12. So this is 12 divided by, if you punch on the calculator, 2 multiplied by 5 multiplied by 6, that's 60. And to calculate the value of C here, you can say the inverse of cos inverse of 12 divided by 6. So here I'll say the angle at C is equal to cos inverse of 12 divided by 60, sorry, not divided by 6 but 60. So here C is equal to cos inverse of 12 divided by 60, that's 78.46. So this is 78.46 degrees. So here I can say the angle at C is equal to 78.46 if I round off to 2 decimal places. So this is how you find the angle of a non-right angled triangle using the cosine rule. Where you have questions, please ask in the group. So we're going to look at the next thing, which is area. So we'll be looking at the next thing, which is area, and this will be area of a non-right angled triangle. So I've said we'll be looking at area. So this is of a non-right angled triangle. So let us draw our triangle again, the simple triangle. So if this is A, this is B, this is C, you have everything like that. So this means that this is small letter A, this is small letter B, and this is small letter C. And the formula that we use when calculating area is, for example, if you have been given the angle at point A, we are going to say area is equal to half multiplied by, we are going to get the B here, the small letter B and the small letter C. So this will be BC sine the angle that you have been given in the question, which is A. So this is the formula that you use when you have been given the angle at A. What if you have been given the angle at B? So if the angle here is at B, we can say half. So this will be half AC, half AC sine B for the angle that you have been given. What if you have been given the angle at point C? So this will be area is equals to half, since the angle is here, so which means half A B sine C. So these are the formulas that you need to take into consideration. Let us now look at an example. So for example 1, I have the triangle in this way. Then this is 3 meters. Then I have 4 meters here. So here I have triangle XYZ, where angle YZX is 120 degrees and the length XZ is 4 meters and the length YZ is 3 meters. And if I'm told to calculate the area of this non-right angled triangle, I need to consider the angle that have been given here, which is at point Z. So I'm going to say area is equal to half So I've been given the angle at point Z, so which means I'm going to get this part and this part. So this, I know that this is small letter y, this is small letter x, and this is small letter z. So this means it's going to be half yz, half yz, half yx, sorry, it will be half yx sine z, because the angle here is at point z. So here we know that area is equal to half y. What is y here? Y, we know that's 4, so multiplied by 4 multiplied by x is 3 multiplied by sine the angle that is at z is 120. So if you punch that on the calculator, if you say 1 multiplied by 4 multiplied by 3 multiplied by sine 120 divided by 2, the answer is going to be 5.20 cubic 5.20 squared centimeters. So here I'll say area is equals to 5.20 squared centimeter or centimeter squared. So this is the area of triangle XYZ. Let us look at the other example. So example 2, the 9 right angled triangle is in this form. So this is C, this is A, this is B. So this is small letter A, small letter B, and this is small letter C. And the angle here have been given as 52 degrees. Sorry about that, let me just check the answer. I've already deleted it, but I think I haven't made any mistake. Alright, we'll proceed. So the angle here is 6 centimeters. The angle here is 4 centimeters. And if I'm told to find the area of this non-right angle triangle, I'll say area is equal to half AC. This will be half AC sine B. Since I've been given the angle at point B here, so it will be half AC sine B. So I know that this is half multiplied by the length A here is 6, so 6 multiplied by the length C is 4 multiplied by sine B, the angle at B, that's 52. So we can say area is equal to, so if you punch out the calculator, 1 multiplied by 6 multiplied by 4 multiplied by sine 52 divided by 2, that is going to give you 9.46 cubic centimeters. So this is going to give you 9.46 squared centimeters. Sorry, not cubic. Cubic is the measurement of volume, but this is 9.46 squared centimeters. And I think for the first example I said squared centimeters, it was supposed to be meters because the length we are given in meters. So that's all about area, where you have some difficulties, you can ask the questions in the group. Thank you. So under trigonometry, we're going to proceed, and today we're going to look at shortest distance. So you can calculate the shortest distance of a non-right angled triangle when you know the side and when you know the area of that non-right angled triangle. So you're supposed to know the side. You're also supposed to know the area. And if you have this triangle in this form, this is A, then I have B here, and I have C. So I know that this is my small letter A, this is my small letter C, and this is my small letter B. And I can only calculate the shortest distance of this non-right angled triangle if I know the area and if I know the side. So the two precautions have said if you know the area is known of this right angled triangle, you also know the side. So the side here that you're supposed to know is side BC, which is A. So you're supposed to know side BC, which is A. And the formula that we use when calculating the shortest distance, you say area is equals to half BH. So the shortest distance in this non-right angled triangle is this distance from A to BC. So as this line that comes from A, as it moves from A to point BC, it will form a right angled triangle. And this is our shortest distance. So we are supposed to calculate this length. And when we are calculating the shortest distance, we use the breadth as BC. So this is going to be our B. So here we can calculate H, which is the shortest distance. If we know B here, the length BC, if we know it, and if we have been given the area, we can calculate our shortest distance. So that's how you can calculate your shortest distance. Let us look at an example. So this is the triangle. Then I have H here, I have T, I have S, then here I have 1.9 kilometers. Here I'm having 1.3 kilometers. And the angle at H, I'm having 130 degrees. So this is 130 degrees. So if I've been told to calculate the shortest distance from H to TS. So if I've been told to calculate the shortest distance from H to TS, so the distance here from this point to this point. So the first thing that I'm supposed to do is to calculate length TS, and I'm also supposed to calculate the area of this non-right angled triangle. So before we calculate the length, let us identify the parts of this non-right angled triangle. So I know that this is small letter H, this is small letter T, this is small letter S. So to calculate TS here, I'm going to say to calculate TS, I'm going to say h squared is equal to s squared plus t squared minus 2 st cos h. Remember that here our h is a small letter h, so I can say small letter h squared is equal to s, we know that that's 1.9 squared, plus t, that's 1.3 squared, minus 2 times 1.9 multiplied by 1.3 multiplied by cos h, that's 130. So h squared is equal to, so if you punch that on the calculator, it's going to give you 8.475370792. So to calculate the value of small letter h, it says squared here and squared here, the square root here and the square root. So there's the squared and the square root, they're going to cancel out, and the square root of 8.475370792, that's 2.92. So that's 2.92 kilometers if I round off to 2 decimal places. So this means the length TS have calculated, which is 2.92. The next thing that I'm supposed to do is to calculate the area. So area, I'll say area of a non-right angled triangle, we say half multiplied by, here I'm going to use st sine h. So half is equal to area is equals to half multiplied by s, I know that's 1.9 multiplied by t, that's 1.3 multiplied by sine h. H here, that's the angle, which is 130 degrees. So the area here is equal to, if you punch that on the calculator, it's going to give you 0.95 squared kilometers. So that's 0.95 squared kilometers. So this is the area. Since I have the length and the area, I can calculate the shortest distance. And I know that my triangle I'm given in this form. This is H, this is T, this is S. Here I'm having 1.3 kilometers. Here I'm having 1.9 kilometers. The angle here is 130 degrees. I know that this is small letter h, small letter s, small letter t. And since I know the length h, so h had found 2.92 kilometers, and the area of this non-right angle triangle I had found 1.95 squared kilometer. I can calculate the shortest distance. So the shortest distance is this line here from H to ST. This is the line, so this forms a right angle triangle. So I'll make this as H, and if I draw the length here, I'll just make the length which is here, which is TS, as B. So I'm going to say area is equals to half BH. So the area, I know that that's 0.95 is equal to half multiplied by the B here I had calculated, which is H, so that's 2.92 multiplied by H. H is the shortest distance, so this is 0.95 is equal to 1 multiplied by 2.92 multiplied by H divided by 2. I'm having 1.46 H. So to calculate the value of H, I'll say divide by 1.46 divided by 1.46. So my H is equal to this, and this is going to cancel out. 0.95 divided by 1.46, that's 0.65 kilometers. So this means that the shortest distance from, so I can say shortest distance from H to TS is equal to 0.65 kilometers. So this is how you find the shortest distance. Where you have questions, please ask in the group, guys. Thank you. We are going to proceed with trigonometry, and now we are going to look at the 3 trigonometric ratios in the quadrants. So there are 4 types of quadrants. We have the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. So in the first quadrant, all the 3 trigonometric ratios are positive. So this means the sine, the cosine, and the tan, they are all positive. Then in the second quadrant, the sine is positive. That means the cosine and the tan are negative. If we come to the third quadrant, the tan is positive. That means the sine and the cosine are negative. Then if we come to the fourth quadrant, the cosine is positive. That means the sine and the tan are negative. So let me just draw these 4 trigonometric ratios. Let me just draw the 4 quadrants. So these are the 4 quadrants. We have the first, the second, the third, and the fourth. So in here we have the first quadrant, we have the second quadrant, we have the third quadrant, and the fourth quadrant. So in the first quadrant, all the 3 trigonometric ratios are positive. Then the angles in the first quadrant, they go up to 90 degrees. So they go up to 90 degrees. Then in the second quadrant, sine here is positive. That means cosine is negative and tan is negative. And the angles here, they go up to 180 degrees. Then if we come to the third quadrant, tan here is positive. That means sine is negative and cosine is negative. If we come to the fourth quadrant, cosine here is positive. That means tan is negative and sine is negative. And the angles in the fourth quadrant, they go up to 360 degrees. And the sine in the third quadrant, they go up to 270 degrees. So these are the 4 types of quadrants. Let us look at some of the examples. For the first example, it reads, find the angle between 0 degrees and 90 degrees which satisfy the equation. So we have cos theta is equal to 2 over 3, and we know that cos is positive in the first quadrant and in the fourth quadrant. And in the first quadrant, the angles they go up to 90 degrees, and in the fourth quadrant, the angles they go up to 360 degrees. And since in the question we have been told to find the angle that is between 0 degrees and 90 degrees, that means we're just going to consider the first quadrant. So to find the value of theta there, we just say theta is equal to cos inverse of 2 over 3. So theta is equal to 48.2 degrees. So that's 48.2 degrees. Let us look at the second example. So the second question reads, solve the equation cos theta is equals to 0.9374. Theta is greater than or equal to 0 degrees but less than or equal to 360 degrees. So the range there have been given from 0 degrees to 360 degrees, and I know that cosine is positive in the first quadrant and in the fourth quadrant. In the first quadrant, the angles they go up to 90 degrees, and in the fourth quadrant, the angles they go up to 360 degrees. So let us find the values of theta. So I'm going to say cos theta is equal to 0.937, and to find the value of theta there, I'll say theta is equal to cos inverse of 0.937. So theta there is equal to cos inverse of 0.937, that's 20.4 degrees. So this means this is my answer in the first quadrant. That's my answer in the first quadrant. Let us look at how we can find the other value. So the other value in the fourth quadrant, we are going to say 360 degrees minus 20.4 degrees, and the answer there is 339.6 degrees. So this means that the value of theta is equal to 20.4 degrees and 339.6 degrees. So these are the values of theta. And the simple way in which you can know the four quadrants, so let me just write them down. So this is my x axis, it's my y. I said here there is all the three trigonometric ratios are positive. Here we have sine, cosine, here we have tan, and here we have cosine. So this is the first quadrant, the second, the third, and the fourth. So the slogan that you can use to master this, you can just say all students drink cachaço. So all students, that means all the three trigonometric ratios are positive. Then students means that sine is positive in the second quadrant, Then drink, so you just represent it by T. That means tan is positive in the third quadrant, and cachaso, that represents cosine, and that means cosine is positive in the fourth quadrant. Let us now look at on how you can draw the graphs of these three trigonometric ratios. So the first graph that we are going to draw is that of sine, and to draw the graph of sine, I'm going to draw my y-axis, and I have my x-axis there. So I have 1 and -1. Then I have 90 degrees, I have 180 degrees, 270 degrees, and 360 degrees. So the first point, it's here, which is 0, 0. That's the first point. The second point, I have 90 degrees, 1. The third point, I have 180 degrees, 0. The fourth point, I have 270 degrees, -1. And the fifth point, I have 360 degrees, 0. So the graph is going to look in this way. So you need to know how you draw these graphs. Sometimes in the exam they can tell you, can you draw the graph of sine, of cosine, or tan? Let us look at the second graph. So the cosine graph. So I have my y-axis, I have 1, I have -1, I have my 90 degrees, I have 180 degrees, 270 degrees, and 360 degrees. So the first coordinate, I have 1, I have 0, 1. The second coordinate, I have 90 degrees, 0. The third coordinate, I have 180 degrees, -1. The fourth coordinate, I have 270 degrees, 0. And the fifth coordinate, I have 360 degrees, 1. So the graph is going to look in this way. So this is how you draw the graph of cosine. Let us look at on how you can draw the graph of the tangent. So I have my y-axis, I have my x-axis. On my y-axis I have 1 and -1. I have 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So the first graph that I need to draw comes from here, goes in this way. The other one comes down here, the other one goes up, the other one comes down. So this is the graph of the tangent. So this is how you draw the graphs of the three trigonometric ratios. And this means we are done with trigonometry. But where you still have questions, you can ask in the group. Thank you very much.